Thanks, guys. So before we get going, I want to. I'm learning Scottish Gaelic, so I wanted to drop a little as we go on here. So, Féiscear ma, everyone. Ismisha Cory. Agus Hamitolikcha Vian show. That's all I'm going to do. Let's get down to brass tacks, though. So the actual title of this talk is Monoidal Identity Elements, or How to Choose a Default Value. So that is weird. And it sounds, I'm well aware it sounds super boring and totally bizarre. And speaking of like the title of the book that was given away, it's kind of along those same lines. It sounds like it's not very useful. But we're going to find out that it actually is. And I'm going to need everyone's help when we're doing this. I'm going to solicit at times information and feedback and stuff. So please, when we do that, shout it out loud and proud.
We're here. Start over.
All right. So who has used JavaScript default values before? They look something like this.
Me.
I have a fan club. That's great. Yes. Awesome. They're lots of fun. They actually save us from often having to do things like this, and this, and this, and this. Just lots of checking of things. So we love these JavaScript default values. They're fantastic. However, the big question, obviously, that the universe is contemplating is what values do we actually give these defaults? I'm sure it's kept you up nights just like it has me. It's really the hot topic. Everyone's talking about it. We could use them like placeholders, like we would with an input element, right? So we put the description of what we want them to put in there, like the name of the first thing, right? Or what about what we think the most likely value will be to start things off? So if we're, I don't know, trying to name a ship, and giving that out to the internet, we already know what the most likely value is going to be. It's obviously Bodie McBoatface. We could throw an error if they don't give us what we want. I say, nope, you didn't give me something, so go away. These are all options. There are endless options, in fact. So how can we know what to do? Without some direction, we're left with a lot of FUDs. And of course, FUDs means fear, uncertainty, doubt, and shame. However, we are going to restore your confidence today. You will be able to stand tall knowing you have chosen the right value for your default value. The secret, my friends, is monoidal identity elements. Mic drop, thank you. You're welcome. Are there any questions? No? Wow. I have a question for you guys. Yeah, thank you. What exactly is a monoidal identity element? Now, for those of you who do know what a monoidal identity element is, and now you can I know exactly what to do. I know how to use it. I'm good. Thanks so much. There are actually some really great talks going on right now. They just started. I don't think you missed much. They're probably still in the introduction. You can go listen to Kent Dodds talk about managing an open source project. You can go listen to Kylie Stewart talking about GraphQL and its many strengths and its evolution to that thing. And I'm sure you will not be disappointed. However, if you're like me, you're one of the sick ones that enjoy the unusual, the bizarre, the unfamiliar. Woo! Let's dive in. Monoidal identity. I noticed nobody left. That's great. I really expected people to leave after that. So thank you. Let's dive into this. Let's talk about monoid. A monoid is an algebraic structure with single associative identity operation and identity element. Binary operation. Let's break that down because that's a lot. An algebraic structure. Let's not fear this. All we're talking about is types. Strings, booleans, numbers, arrays, objects. You guys know what these are. You work with them every day. So not a big deal there. Types. Associative binary operation. You guys remember associativity from like elementary school? Right? You can put the parentheses here, you can put the parentheses here, and it doesn't matter. It still comes out the same way. This is what we're talking about. Binary meaning 2. Operator means it operates on stuff. So operates on 2 things, and it's associative. That's all I need to know. I'm sure you are very familiar with many of these, and we'll go over them. Identity element. This might be a little new topic, new concept for everyone. Not for everyone, for some of us. An identity element is really just it's an element that is of the same type that we're already talking about, the algebraic structure in question, that when you combine or concat, that's the generic term we're going to use for it, with any other element in that same type, you get back that other element. And if that doesn't yet if that's not yet clear, it will be just very shortly. Just put a pin in it for a second. We'll come right there. The thing is that needs to be both true whether it's on the left or the right side of that operator. Right? So it doesn't matter what side of the operator it's on. It still ultimately resolves to that other thing that you're combining with. Okay, so every unique combination of these 3 things, a data type, an operator, and an identity element, forms a brand new monoid. All right, see? Now you know what a monoid is. It wasn't that difficult. It's just a weird name. Don't even need a cream for it. There are only a handful of monoids that can be formed out of the basic data types in JavaScript, and we'll go over those because at the end it's going to be great. So let's start with an easy one, the number type. There are 4 binary operators for numbers in JavaScript, but of those, only 2 are associative. Am I lost anyone so far? So subtraction, division, not associative. So what remains now is for us to identify the identity element, discover what it is. So let's take plus. What identity element, what identity number I, when combined with any other number, gives us back that other number? Shout it out. 0. You are correct. Good job. How about multiplication? 1. You guys are just on the ball. You have discovered the first 2 monoids in JavaScript. The number addition monoid and the number multiplication monoid. Congratulations. You should be talking up here. It's great. Let's move on to string. Strings have just 1 binary operator. However, there are 3 ways of invoking that operator. We can use the plus sign. We can do tag templates and just combine them that way. Or we can actually use the concat method on string. All these produce the same results, or can produce the same results. And for our purposes, they are the same operation. So we have the type, we have the operator. Does anyone know what the identity element would be for this? What string, when combined with any other string, gives us that other string? The empty string. You guys are rock solid. That's right. We have just discovered monoid number 3 in JavaScript, the string monoid. Notice I don't have to refer to it by the operator because there's only 1 string monoid. It's great. How about Boolean? How many operators do we have for Booleans? I heard it, but quietly. Did I hear 3? No, just. Oh, touche. I did. How many binary operators do we have for Booleans? We have 2. We have the AND operator and the OR operator. So this is a little tricky, sometimes for me, a little hard to wrap my head around. But given some Boolean I, what is the Boolean I when combined with AND gives us a Boolean B? You guys are smarter than me because I always have to bust out the table to do. It's like, which one is it again? Yes, true. Doesn't matter what B is, as long as I is true, you get B back. It doesn't matter what side of the equation you put it on. How about OR? It is the opposite. That's right, false. Guys, we're up to 4 and 5. Monoids number 4 and 5. Boolean and a Boolean or. We're cruising through this. Now we're going to get a little more complex. Arrays. We have the KingCat. Much like strings, though, we have multiple ways of concating. We also have the spread operator, which allows us to accomplish the same thing. So we have our formula. Given some array, what array I will give us back that original array? So the empty array. That's right. Now, the astute and pedantic observer will notice that we're not strictly getting back the same array. But for the purposes of monoids and what we're trying to accomplish here, we're not worried about referential identity. We're worried about shape, that they contain the same things, that there's not something different in that array. Not in length, not in stuff. So similarly shaped arrays are the same as far as we're concerned. So yes, the empty array. That was monoid number 6. Now, you guys might be feeling, yes, I got this. Let's go a little faster. Did I waste my time coming here? I promise we're going to get some good stuff, but the lead up is worth it, guys. So let's talk about objects. We have object assign. We can also use a spread operator in the object to accomplish the same thing. And back to our formula, what element will give us back whatever other thing we're combining with it? The empty object. So, monoid number 7, the object monoid. There are 8 monoids that can be created with the JavaScript basic data types. What data types am I missing so far? There's the null and undefined data types. How many operators do we have for those? 0 operators, so we can't form monoids out of null. Plus, they also have the binary operator, and there's only one value for each of those, null and undefined, so there's no way to combine one. We just can't form monoids with those. So what am I missing? Function. Who said that? You're my favorite. Nice. The function data type. This is the fun one, guys. Do we have any operators for functions? What? What's that? Then? Not on a function, on a promise. So, there's a method. You hold on a minute. Don't get ahead of me. Well, we have bind and call, don't we? But those are not binary. Those are unary. I almost said monary. That didn't make sense. We don't. Is that an operator? I don't know. We don't actually have a binary operator for functions. However, as the intelligent gentleman toward the front mentioned, we are just talking about functions. So what we want to do is, hold on. I'm missing it. Hold on. There we go. We need to discover the operator for functions, and we need to discover the identity element for functions. And that, friends, is really why we're here. So, I'm going to do something very ill-advised, and that one. We're going to see if we can figure this out together. We're going to together discover with some live coding what the operator and identity element for function data type would be. So who's got some ideas? Where can we start? Let's start with the operator. We don't have any operators, so we know we've got to make one. But let's use maybe something as a starting place. Let's take something we already know. How about, I think numbers are pretty easy. So let's start here and let's reverse engineer it as a function. So if we want to turn addition into a function, obviously, not that hard, I don't think. We create an add function, the quintessential add function, right? Because everybody uses the add function all the time in production enterprise grade code. It's going to take a number A and a number B, and it's going to take that A and add it to B, and congratulations, we've created add, the function. So if we have, right, 1 plus 2, we get 3. And if we turn that add into our function add, it looks like this, right? Nothing super crazy here. And we still get 3, yay. Okay. So we know we can turn operators into a function. But what would the operator, if we were to make an operator for functions, what would that operator for functions do? With add, when we're combining, we add. With strings, when we're mushing them together, we're concating. When we're mushing objects together, we're merging. What does it mean to mush two functions together? Oh my gosh, you guys are way smarter than me. We're just going to skip to the end. How about that? We can compose functions. So if we have function A, oh, here, let's do this. Everyone, when we say compose, who doesn't know what compose? Well, man, that's negative. Everybody know what compose is? I'm going to just real fast. This is a super not correct, but displays the intent of it based on what we've already talked about implementation. So function 1, function 2, to compose two functions together, to mush them together, then what we have is function 1 takes the result of function 2. Right? Whoopsie, come on. However, because we're talking about monoids, and monoids have to take a data type and a data type and create the same data type, we have to return a function. Otherwise, function 1 could return anything, and then we wouldn't have a monoid. So we got to return a function. Great, we have a function, returns it, and then we mush those two things together when we call that function. And because one function here takes an argument, this function 1 takes an argument, function 2 doesn't, that doesn't make a lot of sense. So why don't we go ahead and give it an argument like this. This is function composition of two components. If I could create syntax correctly. There we go. So if we wanted to compose function 1 that, I don't know, takes in a number, and function 2, well, takes in a number and adds 1 to it, and this other one also takes in a number, and let's say it adds 2 to it. Of course, that returns a function. We got to call it. We give it 3, and we should get not 3. Oh, thank you. Typing too fast. So we get 6. Hey, we composed functions. Good job, guys. Way smarter than me. Let's, oh no. I knew that was going to happen. Oh, there we are. No. That's not me. Oh, you can see my speaker notes now. How about that? We get composition, function composition for our operator for functions. Now, what about, because this is the monoidal identity elements talk, not monoids generally. So we have function type, we have compose as our operator. Does anyone know what our identity element for function would be? What function, when composed with any other function, will give us the same result as that other function? Any ideas? Yeah. See, when I first was, ages ago, thinking about this, well, not this, when I was thinking, what default value could I give something that expects to be a function? I was like, obviously, no op, right? Clearly, that makes sense. You give, if I have a function that takes a function and I need a default value, I'm going to give that function no op. However, we can actually find that this function is preferable. So preferable, in fact, that there's a utility for it in Lodash and Ramda and many other utility functions. I don't know if you noticed this before, but there's a thing called identity function. This is actually the name of the identity element for the function monoid. It's a very clever name if you think about it. So the identity function is our identity element. And it turns out, guys, how are we doing? Okay. It turns out that when we utilize monoidal identity elements as default values for our function arguments, for when we destructure, for any of the time that we where we might want to put a default value, if we use the identity element of the monoid that we're dealing with, that we can effectively eliminate just a ton of our guard clauses, null checks, well, maybe not null checks, just undefined checks, which are mostly what we're doing. And if you're doing other things such as doing like transforms in your API layers, like as they come in, make sure that the shape is correct. If you're doing some of these other things and you rely on the monoidal identity element for those default values, then it produces much cleaner code. If you look at the example here, you know what, I'm going to just do this because it's super annoying having my notes there now. If we look at the beginning here, we have this hot mess that you can see with all these checks in here. And this guy at the end is the same thing, way over here. There. Same function, but utilizing the monoidal identity elements as default values. If we do this, we have a lot cleaner code. We also are able to take advantage of self-documented code, because if you look at this, you can see, oh, I have this config argument in here, and I can see that's an object. Awesome. We have this do stuff for active item argument, and I can see that it's meant to be a function. I have this ID thing in there. List is meant to be, I named these obviously, but maybe in the code you're working in, they're not so obviously named. List is an array. Delimiter, if we're splitting strings, we can say it's a string. We need to know it's a string. This self-documents our code, lets us know, our future selves and additional developers, what we're dealing with here, what to expect, and what kind of things we can operate on. But even more than that, who uses TypeScript or Flow or something like that? Who would prefer not to, but can see the benefit of it? Okay, good. I kind of fall into that camp. I see the benefit of it. I'd kind of prefer not to jump 2 feet first into it entirely. If we did something like this, do you know what we take advantage of? We take advantage of those tools' ability to statically analyze our code and to infer those values. So when we get the code checker, where it's giving us the definitions and stuff, or saying what our signatures are, it can tell us this function takes a string. It knows that because you defaulted the argument to a string, and it can do that for us. So we can get quite a bit of the benefits from these static type checkers and compilers without having to buy completely into the whole ecosystem. Now, if you have, that's great. It's awesome. Congratulations. It's terrific. You can still use this, and it's wonderful. But you don't have to, right? And you can get much of the same advantage from that. So hopefully, at this point, you've learned a few things. You've learned that the word monoid is what it is, and that it's not maybe as boring or as scary as you thought it was. You have a little bit of introduction to category theory. I don't know if you knew that, and functional programming. And hopefully, you're able to take this concept back and apply it into your code in a way that will benefit you, your future self, and your team a little bit better by self-documenting and having a lot more confidence in the way that you write your functions and whatnot. So, Thank you.